Welcome and to this video. We will talk about open source models that combine vision and LLMs. They allow performing tasks involving images and a text prompt to respond with text. Today, these models represent the state of the art in computer vision because the refinement related to their fusion with natural language is such that, as it stands, they can answer relatively complex questions. In our example, we will see that this model can perform unique object counting on video. Here we ask the model to count the number of unique ornaments on the rotating Christmas tree. Without any adaptation, the model responds with 24, which is the exact count on the tree. It's impressive because it's a complex task on infrequent images. Indeed, it's quite infrequent to find rotating Christmas trees on the web. This model is open source and can be adapted with just a few hundred examples for your industrial application, for example. Unlike commercial model integrating vision that cannot be adapted. The model we are talking about is InternVL, and shown here in orange in this benchmark. It is currently available in versions ranging from 1 to 80 billion parameters. This allows, through knowledge transfer, to auto-label your data with the most powerful versions to adapt and improve the performance of the faster versions. If you need real-time processing, you could use it to automatically label tens of thousands images to train an older generation model like YOLO, which is very fast but needs to be trained with tens of thousands of examples to become accurate. The foundations of this model began a few years ago, first by aligning the characteristics of vision and language. As you can see in this diagram, a contrastive gradient descent modifies the text and image encoders to match the representations of the image and the text. Then, step by step, the vision model is integrated into the LLM. It is then gradually adapted to more advanced tasks of describing image content. For example, by adapting it to answer specific questions about images. Thanks to the large volumes of images associated with textual content available on the web, this type of model becomes capable of generalizing the understanding of visual content, even to the physical interaction of objects in the image. Thus, we can understand that these models combining vision and natural language are much more valuable than classic vision models like YOLO because these older generation models are unable to generalize. They need to be completely retrained to apply to new subjects. This comes with very high and demanding human labeling costs, especially since a company's data is often confidential, including the labeling instructions themselves. Finally, business needs can change quickly, and this need for flexibility is incompatible with manual labeling tasks, involving data sets of tens of thousands of examples. So, this is why the model presented here is strategic for computer vision. In its latest version, InternVL implements last vision and LLM components with tile-based vision management that allows handling high-resolution images or even image sequences, which is of course associated with refinement tasks related to visual sequences. Next time, we will see how to use the code of this model. See you soon in the next video.